So this is our NASA Mars Lander final report, the first year engineering lab, section 1, summer B 2025. We are team 5, Egg Haven, and our team members consist of Bella Gaddinser,
Emma Smith,
and Tamaya Smith.
So here's our overview. We have our introductions, background, requirements, final design, manufacturing activity, test results, and our conclusion. So here's our introductions for Team 5 at Haven. I'm Bella Gaddinser. I'm the project manager.
I'm Tamaya Smith, the construction manager.
and I'm Emma Smith, the verification and test manager.
So here's our RFP provided by NASA for our project of our lander. So here's our phase 1 summary of the customer requirements documented. So the Mars lander shall deliver astronauts to the surface of Mars. The Mars lander performance shall be demonstrated during video recorded tests on launch day. The Mars lander shall carry 2 pilots, which are eggs, and the Mars lander shall be reusable. So we can use it 2 or more times on the 3rd floor as well. So here's our phase 1 summary of the contractor requirements documented. So I'm going to read them out. The Mars lander shall deliver astronauts to the surface of Mars. The Mars lander's demonstrator vehicle shall survive the impact of a 11-foot drop. The Mars lander demonstrator vehicle shall protect 2 eggs from damage, weighing up to 59 grams each. The Mars lander team shall deliver a 10 to 15 minute Zoom presentation, which is this. The Mars lander demonstrated vehicle shall be dropped 2 times at least. The Mars lander demonstrator vehicle shall withstand a drop from a height of 11 feet. The Mars lander demonstrator vehicle shall land on a tile surface. The Mars lander demonstrator vehicle shall be dropped from the atrium stairs. The Mars lander demonstrator vehicle shall be released by a designated test engineer. And then finally, the Mars lander demonstrator vehicle shall use eggs provided by Dr. Burrs.
Okay, and the final design is here that we see. We have the top, front, and side view. You can see the bag that's held together by the rubber band that's connected to the box, and also the pool noodle that's taped to the bottom. And as far as materials go, we use tape scissors and scissors. That's $0. We use a cardboard that's 2x2. That was $5. We use a pool noodle, 1 full size, also $5. We use 1 square foot sheet of bubble wrap. That was $2. 4 plastic grocery bags, $2. $1. 10 rubber bands, 50 cents, and then 10 cotton balls, which was $1.05. And that all adds up together to 15. And as you can see here, there's all the materials that we have. So we have the rubber bands, the bubble wrap, the cardboard, the tape, the ruler, the plastic bags, the scissors, the cotton balls, and the pool noodle. And as far as the construction plan goes, the first step that we did was put the cardboard box together and tape the top of the box. Taping the bottom and leaving the top open. Then we cut off the top flaps. Step 3, we cut the holes on the parallel sides of the long side, I believe. 4, we taped 2 rubber bands through the loops that we created. Step 5 is we cut the open of the grocery bag into 4 equal parts and then tied a knot around that. Step 7, we cut up the pool noodle into 4 pieces and then taped them on the bottom of the box. Step 8, all the leftover materials from the pool noodle we placed inside of it to have extra cushion. Step 9, we also created an extra layer with the cotton balls and the grocery bags. And then step 10, we wrapped the eggs in bubble wrap and a grocery bag. Step 11, we placed the wrapped eggs inside of the cushion of cotton balls and pool noodles. And then step 12, it was ready to launch. And for the construction plan, some things that we decided to change was we cut all the top flaps off because it was getting in the way of the grocery bag that was acting as a parachute. We needed more air to slow down the drop. All the extra materials that we had, we decided to add it into the box for extra cushion. And along with the extra cushioning, we had extra grocery bags, so we decided to wrap that around the egg along with the bubble wrap. And here are some pictures of our final design.
Okay, and then these are our test results. So our test date was on July 29th in the building A atrium from a height of 11 feet. Our vehicle was in length 30 centimeters, the width was 26 centimeters, and the height was 22 centimeters. Our load time for both of our pilots was 10 seconds for both of them. After the drop, the vehicle stayed intact with a length of 30 centimeters, a width of 26 centimeters, and a height of 22 centimeters. However, we did have a pilot get ejected, and it was crushed by another vehicle. So that was Ashley. So Ashley did pass away in that process.
Yes.
And then this is a video of the loading and drop. And we are the second ones in from the left side. And then the next video is a video of the pilots after the launch. And then this is our deceased pilot. You can see the crack along her middle there.
So, our conclusions, comments, and takeaways. So, what did we accomplish? So, here's a summary of design. The design process was beneficial in completing Team 5's lander. We had viewed over 10 design ideas to support the two eggs, Ashley and Mary Kate, and Team 5 was able to decide on the final design, green components of our top 3 designs all together. With this decision, Team 5 had decided on the cardboard box, rubber bands on each side to hold the plastic bag with pool noodles to bounce the fall on the bottom of it, with inside the box containing the pool noodles, cotton balls, and bubble wrap, as well as the extra plastic bags. This design was thought to have a slower fall with the bag and rubber bands, a safe lane with the pool noodles on bottom, and a cushion inside for the eggs with the pool noodles, cotton balls, and bubble wrap. So here's a summary of our assembly. Our assembly was successful in completing the project on time. We had finished it way before time had been called. Our team had worked together to cut pieces off the cardboard box, place tape on each section of the box to hold side pieces together to form that box shape, and we had worked together to create the best formation of a bag with rubber band strings attached. However, majority of the time was spent on figuring out the best position of the plastic bag to ensure airflow would get to the bag to slow the fall. More time should have been dedicated to elongating the rubber bands and working on a top cover of the cardboard box to ensure items would not fall out. So here's a summary of our test results. The vehicle was 30 centimeters in length, 26 centimeters in width, and 22 centimeters in height. The pilots for Team 5 were named Mary Kate and Ashley Olson. they were able to be loaded onto the vehicle with a time of 10 seconds. However, when lowering onto Mars, Ashley was ejected from the vehicle, but remained safe inside an extra layer of protection until another vehicle landed on and killed her. The devastated Mary Kate was able to unload with a time of 11 seconds. All in all, the vehicle stayed intact with a length of 30 centimeters, a width of 26 centimeters, and a height of 22 centimeters. So here's a summary of our redesign effort. If we were able to change the original project of the lander, a big effort would be in closing the top of the box and creating a longer chain of rubber bands for the bag. During the landing, Ashley's packaging had fallen out of the cardboard box, leading to her demise. If there was a top to the box, such as a cardboard layer on top, this would have prevented this from occurring. Also, if we had a longer chain of rubber bands connected to each other, the plastic bag would have even more time to gain air inside, slowing the fall even more for the box, having a safer landing overall. So thank you for your time, and Team 5 thanks you.